Hello there, and welcome to this, the 232nd edition of DF Direct Weekly, not including specials. Massive show to get through this week. What can I say? Gargantuan news stories. But first of all, let's introduce the panel. Alex Battaglia, hello.
Yes, I'm over here looking at multiple games behind the scenes for videos this upcoming week. You're going to like them.
Okay, good stuff. And Oliver Mackenzie, hello.
Yes, Rich. Very wild and wacky week here. Lots of controversial personalities clashing and some very exciting news from the world of semiconductors, I would say.
Mm-hmm, absolutely. But before we go on, we are now fully independent and we could do with your support. So please do consider supporting us via Patreon, patreon.com/Digital Foundry, or examine our merchandising wares. And that's at store.digitalfoundry.net. But with that, let's move on to our first news topic of the week. Okay, well, we've got some, what can we say, housekeeping here. It's to the point where games are coming in either unfinished or having to be sort of put on the back foot somewhat owing to our existing schedules. So we don't actually have any launch day or embargo coverage for Dying Light the Beast. For a couple of reasons there. Features missing from PC, which we'll talk about shortly. Xbox code not being available, but we're going to talk about what we can talk about. We're going to talk about the PlayStation 5 version with Oliver and PC with Alex. And Alex, you spent the day with Dying Light the Beast. You've got a lot to talk about here. You've sent a lot of clips our way for our perusal. So let's talk.
Yeah, so as Rich discussed, missing features from the PC version right at launch, which is kind of what made us hold our hand on the coverage, like a full coverage, because we'd be having half the story out and then the game would be patched at some point and we'd be missing a large part of that story. So we decided to compact it into DF Direct here, but still a lot of information that I can go through. The game is at launch missing all the ray tracing features that were there in Dying Light 2. The game was scheduled to have them. I'm pretty sure pre-release builds of the game possibly did have them, and then they were removed. So when you get in game now and you go into the main menu, the options menu there, the settings for things like global illumination, shadows, and reflections, as well as flashlight now do not have the ultra setting, which would previously turn on ray traced versions of all those things. Those will be added post-launch. There's a note out there by Techland saying they wanted to make sure that they were polished and ready, and they weren't in time, and it'll be added in shortly. But still, you can load up the game right now and play it. And actually, I think it plays really, really well, barring a few caveats that I'll get into later. One thing you'll notice right when you get in the game, depending upon your PC, in the main menu, right above, I think, like the new game button, you'll see pre-compiling shaders. This super brief on the 9800X3D. Blink and you'll miss it. And I'm pretty sure on a lower end CPU, maybe you'd see that for longer, but the game does do at least a opaque pre-compiling step. Getting in game, without talking about any of the graphics here, without ray tracing, this is next to something like Doom the Dark Ages, one of the most fluid frame time experiences I've had in a long time, covering Digital Foundry games. Like, seriously, just running around outside, you're not right now seeing 9800X3D DLSS for quality mode, max out settings without ray tracing, VSync off, reflex off, super fluid frame times, just like 150 FPS, little tiniest of little things that are like going up to like 6 milliseconds or, like 10 milliseconds every once in a while, not even very commonly. It's a very fluid experience there when you have an unlocked frame rate actually currently in the game. So that was like my immediate impression. I only caught one instance of one frame time spike during my entire play, and I sent the clip to Oliver, and it's going to be going on right now. It was like one frame time spike, and that was about it. I played the game for 3 hours. That is a very different experience than, for example, Borderlands, which we talked about last week, where it was immediately apparent something was wrong. Here, did not have that impression at all. So I'm playing the game without ray tracing here. I was playing it at 4K, locking it to 60 just for the purposes of YouTube. It was running super fluid, and I actually thought it looked, without ray tracing, barring a few things that I'll talk about, really, really good. And actually the lighting I thought was a lot better than what I saw back in 2022 in Dying Light 2. And at first I wasn't sure what I was seeing. You just like look in any area, there's a lot of indirect shadows underneath things, like larger structures. There's bounce lighting in areas that has directional attribution to it. Essentially, like usually with probe lighting, directionality is lost, but here it's still in the image. And it actually looked pretty good. It wasn't getting a lot of the fine detail, of course, but it was hitting all like the larger structures. And then I went up to a couple of puddles. And when you look in a puddle, you'll see that there's screen space reflections for any of the local objects or things within the local field of vision. But then when you move out of screen space, you'll see that actually there's still like some color and shapes in there that line up with the environmental geometry. But I was just like in random locations. I wouldn't expect that to be the case in a game that uses cube maps, for example. And then I went into this one courtyard here. And when I look down on the puddle in the courtyard, there's like trees around me. There's like buildings with a variety of sizes and shapes on them. And I look around and I look in that puddle and they're like, oh, there's like cubed versions of the geometry in the puddle. And I looked at it also like the indirect lighting in other areas. And there's kind of like cube-like outlines. If you actually look, cube-like edges in some of the indirect lighting, especially within the shadows. And based upon that and the fact that it lines up pretty well with the world lighting, a lot of the reflections, I actually think we're looking at some sort of form of like cone traced voxels or something like that for the indirect lighting here and Dying Light, the Beast. And it's pretty different. And that's a pretty large change up both visually and technologically in comparison to what we had in the base Dying Light 2 game in 2022, where there was a huge upgrade visually to turning on ray tracing. And here we don't have ray tracing at launch here. But I imagine that when you do turn it on, the biggest areas you'll see differences in will be in smaller objects, and as well as more detailed reflections. But here, I actually think the lighting looks pretty darn good, all things considered. You go in any one area and you'll see a lot of indirect shadows, surprisingly okay bounce lighting. It's just really indoors that you see issues. And in indoor sections, send also a video to Oliver here. Indoor sections, like character models, can look a bit weird in cutscenes in indoor sections if they're not directly lit. They can just look kind of weirdly glowy. You'll also see in a lot of indoor areas that the lighting is just handled by spotlights that they'll turn on and off the shadows from them as you get closer. And so it kind of looks awkward as you walk towards objects and all the shadows just kind of pop in more or less. And that doesn't look too great. As well as in a lot of the outdoor scenes, sometimes at night, which I'll talk about in a second, you'll see a lot of non-shadow casting lights. They're just kind of like, they almost look like they forgot to click shadow casting for them, because it's just like, there's only one light in the scene. Why is it actually, it's a little bit bizarre, but you can see that occasionally. But overall, I think the game looks pretty good, even without ray tracing at the moment. And it ran really well. And one thing I also want to talk about is that nighttime in this game is very much so like nighttime in real life outside of a city, especially here since, it's post-apocalyptic. There isn't any like city lighting anymore. It is incredibly dark. Like you cannot see anything, only like what your flashlight shows in front of you. And it is hella scary. It is very well done. It's a lot scarier, I would say, than Dying Light 2 is in the night sections. And it was also very hard. The game seems to be a bit harder this time around in terms of both navigating as well as you take quite a bit of damage and your weapons degrade pretty quickly. So you have to be pretty careful. But yeah, all that good stuff. I think it's a great experience, even without ray tracing right now, but I think it's going to be a better experience, hopefully, when ray tracing gets in there. But still, there's still some issues to talk about. One issue I'd found with the launch version of the game is that all of the upscalers that I could try out on an RTX 5090, for example, all had issue with the game's screen space reflections. Basically, as you're seeing here in this IQ comparison, the only image quality treatment that doesn't kind of resolve the SSR in some sort of like speckly and kind of way that doesn't handle light transitions very well is the game's TAAU. I don't know why that is, but that is the way it is at the moment. I couldn't test FSR4, which the game supports through driver upgrading. So that was one issue. Another issue that I found is that when you play the game with reflex on, so that means if you're using DLSS 4 or DLSS 3 frame generation or whatever, or just playing the game unlocked with reflex on, it causes very problematic frame times. As I was showing earlier, if you play the game with VSync off and just run around with reflex off, the frame times are actually pretty sweet. They're awesome. The game runs very fluidly. But as soon as you turn reflex on and run around any area of the game, you're going to be, like the frame time kicking up constantly to like 14, 15 milliseconds repeatedly for no good reason. And the game starts to look very non-fluid on anything of a VRR display. You'd have to cap it, which takes out the whole point of using reflex in the first place. And it kind of makes frame generation, at least on the Nvidia side, which I did test, superfluous. You can't turn it on without the game looking really, really dodgy. So at the moment, that is a bug. Definitely, reflex probably shouldn't be doing that at all. And it doesn't look very good. But other than that, I think it was a pretty great first experience. I didn't get to test lower end kit, but based upon the 9800X3D having no frame time issues, usually it shows frame time issues that other CPUs have just in a lessened form, but it didn't have any here of meaningful notes. So I think it should be pretty good on other systems as well.
Mm-hmm. Yeah, performance. It's interesting because obviously for YouTube purposes, you capture 60 frames per second for doing image quality comparisons and whatnot. However, unlocks performance on the 5090. It's like north of 130 frames per second in 4K DLSS quality. So yes, it is performant. It is fast, and the frame time line there would that every game be like that. But that reflex thing is certainly a weird situation, right?
I've seen it before in games. Well, reflex. So one thing that reflex will do is it will turn off all frame queuing. Yeah. And some games, not all, but some games have problems when that is the case. They weren't designed around that, and they hide a lot of stuff. So maybe that could be the issue. Maybe the engine isn't very good reflex. I didn't try Dying Light 2 with reflex on ever, so I don't know. But that could be an issue engine side rather than an issue with reflex.
Mm-hmm. Yeah, it is a shame we can't talk about ray tracing because, it's ultimately when you've got that much headroom on a 5090 at 4K, you kind of want to use it potentially for improved visuals, right? And certainly some of the issues you've pointed out in terms of lighting may well be resolved just by having decent ray tracing. And historically, Techland have put a lot of ray tracing features into their games, into Dying Light 2, etc. But certainly a promising start, but there is the sense that possibly needed a bit more time to get it right. Oliver, should we talk about the PlayStation 5 version of Dying Light 2? Dying Light the Beast. We can talk about Dying Light 2 if you want, but
yes, Dying Light 2. Dying Light 2 I covered on Last Gen consoles back 3 years ago, so we could talk about Dying Light 2 if you wanted to.
Let's do it.
But I imagine we should talk about Dying Light the Beast, which I would agree with Alex there that it does look quite a lot better than Dying Light 2 with that very nice GI presentation. I'd say one thing that's really nice about Dying Light the Beast relative to Dying Light 2 is that it's set in these kind of forested areas that I think look quite beautiful with all the nice foliage and the really nice indirect diffuse GI response. And they just look very visually pleasing, and they have this rich look that I quite liked. At a distance, it's not quite as impressive. Like when you look into distance, it has that kind of shadowless look a little bit, at least on consoles, which kind of reminds me actually of Dying Light 1 on consoles. The distant lack of shadows totally on consoles, and then on PC that was rectified to quite a large degree. There are some elements that you can tell like this is clearly a cross-generation game, like the various rock formations and things like that. They look a little bit chunky. They don't really have that kind of next-generation level of polygonal fidelity that you might expect. In terms of kind of the raw metrics, I thought image quality was quite good. On PS5, it counted to 1080p in performance mode, probably with some temporal upsampling there. And then in quality mode, it was a bit above 1440p internally, at least in the shots that I tested. Performance was very good as well, not as good as Alex's 150 FPS or whatever with his 10 millisecond stutters, but it was 60 FPS locked in the content that I played and 30 FPS locked in the quality mode, as you might expect for a game like this. The downside, like PC, there's no particular signs of ray tracing. So the reflections are SSR with that kind of voxely fallback, like Alex mentioned. GI, again, looks very similar to PC, looks like that kind of voxel GI solution that Alex is hypothesizing here. The shadows are very high quality, but they look shadow map based to me. They don't seem like RT shadows in either mode. And there are some screen space shadows layered in as well. Like they use kind of all the typical bag of tricks for shadowing that last gen games often use. And the AO kind of looks like, SSAO to me. It looks similar in both modes. So yeah, PS5 Pro, I did check that out as well. And I did not check it out for too long, but it does not seem, again, all the same list of caveats, all the same list of exceptions to this RT stuff apply basically to PS5 Pro. I did not spot any evidence of RT techniques, which is interesting because now this might be an issue common to multiple platforms with this title, obviously. But if you go over to the PS5 version of Dying Light 2, that had RTAO, I believe, in the quality mode on PS5 there. So you'd expect, especially given that the developers talked in an interview last year that I saw, that they want to take advantage of everything the PS5 Pro has to offer. Maybe, a feature like that would be in the offing a little bit later on, but it's not here in this initial release on PS5 or PS5 Pro, unfortunately. So overall, I think this is a really good looking title. It's not tremendously ambitious necessarily because this is shipping. It's not shipping day and date on PS4, Xbox One, whatever. That's coming down, I think, in a couple months here. So it is arriving on those last generation systems in the end. I don't know if they would preserve all the visual features, including the nice GI or whatever, or if it would be stripped back somewhat, but they are shipping it on last generation consoles. But, it's a good looking game. I see a lot of people really commending this game on PC, and I would certainly agree that the game has very good performance as well on consoles. But it is like a cross-generation title. It's not like pushing out the most advanced, like virtualized geometry, virtualized shadow maps, ray tracing, whatever. It's not like pushing out that kind of cauldron of technologies. It's more of a cross-generational title, like a very, very good-looking last-gen title enhanced with better image quality and performance and all that good stuff. But I was quite pleased with the way that it looks at the moment for sure.
Yeah, there is something to be said about a game that may not be pushing the absolute state of the art in visuals, but just runs really well and looks nice, subjectively looks nice. And I think that's what we're getting here. Yeah, I think we should talk maybe just a bit about why we aren't here on embargo with review coverage. Obviously, the PC side of things, we couldn't really, it wasn't complete. There's key features missing. Ray tracing isn't there, which may well or may not extend to the console versions. On the console side of things, PlayStation 5 code, no problem. Xbox code supplied but didn't work. And it should be working now at launch. And I guess this leads me on to something else which is slightly concerning me, is that it's actually becoming significantly more difficult to cover Xbox. We got a review coming up soon where we still don't have Xbox code. And then we had Dying Light, the Beast, where, the codes just didn't work. We really do want to support Xbox. But, if we don't have code, that's a problem. And, I'm just thinking about Metal Gear Solid Delta last month, right? We had a PlayStation 5 and PS5 Pro review at embargo because that was the code we were given. We would have loved to have done Xbox at the same time, but we couldn't because we didn't have the code. And actually, that version turned out to be, not solving the PlayStation's problems, but it did seem to mitigate them to a certain extent, which I would have loved to have been there on day one in that particular coverage. As it is, we produced an Xbox video a week later, which had a fraction of the viewership of the video that came before. So the amount of people that know about the Xbox code is significantly less. So I don't know if this is something where Microsoft maybe should step in and help out a bit to actually, ensure that outlets are actually seeing the Xbox versions of the game. Yeah.
The downside there too is that if we're not getting the viewership and people aren't interested in that kind of Xbox code after the fact, then it might be something we have to consign to like a D After X segment, or we might not even be able to cover it at all in some cases, right? If we aren't getting that code kind of at the same date and time as the PS5 code pre-release.
Yeah. I just want to sort of stress that we really want to talk about the Xbox versions, but it's difficult if we don't have the material available. And it's to the point where, several games, including Metal Gear, actually, we actually bought the Xbox version on day one, simply to be able to get any coverage out of it at all. And it came a week later than PlayStation. It's not what we want to do, but it's it's where we are at the moment. So hopefully something can be done about that, because it's not great, and it sort of sends the perception that we don't care about Xbox, which is certainly not the case. We really want to have full coverage on embargo, preferably, but that does require code, right? Mm-hmm. Anyway, we shall return to Dying Light. The extent to which we can return to it, bearing in mind the schedule at this point, don't know. But maybe we'll return to it in D After X. I guess we should move on, though, to the next news topic. Okay, big news, big semiconductor news. This one kind of came out of nowhere. News that Nvidia is now going to be collaborating with Intel across a range of products. And the implications of this deal are sort of quite extraordinary, to the point where Nvidia has become a shareholder of Intel. It's going to be purchasing approximately 215 million shares of Intel, giving it roughly a 4% stake in the company. And obviously recently, I mean, Intel's not in a great place at the moment. This is happening weeks after the US government acquired a 10% stake in Intel. Obviously, though, the news that Nvidia is getting involved with Intel has caused a stock price rally, and especially for Intel, a small bump for Nvidia. But, this looks like intriguing news. Products to come. I think probably the key things that is bringing about this collaboration is probably more enterprise and data center driven. But we are being promised consumer level products that will have Intel x86 CPU chiplets paired with NVIDIA RTX graphics chiplets, which, wow, that would be quite an impressive collaboration. Alex, what's your thoughts on this? I guess the key thing to stress is that this deal has just happened. So, it's not as if 6 months down the road, we're suddenly going to be talking about Intel/NVIDIA laptops or handhelds or whatever. This is going to take some time to actually amount to anything. But it's quite an extraordinary state of affairs, right? I mean, could you imagine this happening like this time last year? Probably not.
No.
Crazy.
Yeah, it's. I think this is really going to save Intel in the medium term. As an injection of money, as an injection of perhaps using its fabrication resources, things where it's been struggling both on those ends most recently, as well as offering them a new portfolio option for products that they didn't have in the past. And I think from the NVIDIA side of things, it partially solves the one issue they've had for a long, long time now, is that they didn't have an x86 license, which probably what history looks like if NVIDIA also had an x86 license is something I've wondered about. But they just never had one. So they couldn't enter the CPU space like all the other companies can potentially, and they've had to rely on ARM, usually for purposes of like SoCs that they used for like automobiles or server applications and things like that. But that is still a barrier because a lot of code is still not written against that. It's written against legacy x86, x64, and this changes that around. Now they'll be able to offer products combined with their GPU technology, apparently also customized for it as well too. That's kind of part of the press release regarding this, and will give them a whole new stake in the market in all those areas where x86 is still very valuable. And I am very curious to see what that looks like. As someone who's mainly interested though in gaming technology and graphics technology and those applications of it, I'm very interested to see what this will mean towards mobile offerings for NVIDIA chips. In the past, they've been limited to dedicated GPUs. As a part of this, you'd have a dedicated GPU and then maybe an AMD or an Intel CPU there, possibly with its own integrated GPU at the same time. And you'd have these like Optimus issues in your laptops and things like that. Sorry, I do not like Optimus at all. I've never liked Optimus. It never works the way I want it to. And here, the power efficiency offered by actually having the GPU on the same SoC as the CPU and no extra stuff to fumble around with, no PCIe potential to go over anymore. Shared memory pools. There's a whole new class of products that NVIDIA can bring out that would be very interesting. It could mean things like Steam Deck-like things, could be new laptops and new form factors. There is a whole lot that can be brought about by this, but we're at the very beginning, so I can only begin to dream of what will end up happening in the past. But for me, this is very interesting because there's segments of computing that have had a lack, I would say, of competition in them as of late. Steam Deck likes are a part of that. I don't think the Intel, what they've offered, has been very competitive, but NVIDIA, on the other hand, I think could offer something there that is very competitive. So I'm pretty excited about the future for this, and I'm happy to at least see Intel not going under in the immediate to near future.
Yeah, I think, when we first heard the news, it was like, wow, now NVIDIA can do x86 processors. But then the question was raised as to the nature of an x86 license, because there's a lot of co-agreements between Intel and AMD, about x86, x64, et cetera. So I don't think there's actually I don't think Intel are going to be granting a license to NVIDIA for that reason. So all of these products that will be coming out will be ostensibly Intel products, but with a heavy graphics and AI input from NVIDIA there. So that's interesting. So I don't understand quite how that deal is going to work out to be exceptionally favorable for NVIDIA. But I guess we'll need to wait and see. From a gaming perspective, in the short term, we are going to be seeing NVIDIA's GB10 processor, which is an ARM CPU core with something akin to a RTX 5070 integrated into one mega chip. And but the success of that in gaming terms is going to be entirely down to how robust the ARM translation layer is in Windows, which is still up in the air at the moment. We just don't know, certainly based on the Qualcomm products we've seen coming out. So from a gaming perspective, I think there's those x86 RTX SoCs are going to be very, very interesting when they eventually come along. In the short term, it's all about ARM with all of the question marks that raises. Data centers, though, I think that's possibly where AMD might be getting a bit sort of concerned, because obviously their competition has been fragmented, extremely strong competition from graphics, not so much from Intel. But, this sort of changes things around now, potentially. So, yeah, that's going to be certainly interesting. Oliver, I'm curious about your thoughts on this.
Yeah, I think this is really exciting news just because it gives NVIDIA this really clear pathway into, I think, more mainstream laptops, thin and light laptops, ultra-portable laptops, and gaming handhelds, which could be a great way to marry like the convenience of an APU, the power efficiency of an APU potentially, with higher performance, with more feature-rich graphics relative to what we've seen so far. Especially in like those handheld form factors where you don't have a cooling assembly that can cool multiple high-end chips or anything like that. You're dealing with a form factor that's only really suitable for like SoC type devices, maybe multi-chip type devices, but in one package. So yeah, I am very interested in this just for the implication for handhelds, especially considering how stagnant handheld chips have been over the past 3 years. Like, you go from Van Gogh to Z2 Extreme, and it's very much of a kind with each other. The only real kind of big bump you get is going to something Strix Halo, which is just absurdly large for a handheld. Maybe this could marry kind of the better aspects of like a Van Gogh chip in terms of the size, in terms of reasonable TDPs, with more of kind of the performance and the feature level that you might want to see out of a higher end solution. But obviously at the same time, NVIDIA does have upcoming ARM-based SoCs based on the GB10 chip, I believe, which I think are codenamed the N1X and N1, which I think the N1X is for desktops and N1 is for laptops and maybe other ultra-portable kind of devices. But that's obviously, in Windows land, that's a warm effort. That's Windows on ARM. And they're really leaning on Microsoft and their translation tech to make that work. And I think so far, you look at the Snapdragon Elite devices, the Orion-based devices, and those have not lit the world on fire in terms of sales. Now, maybe that comes down to price, maybe that comes down to different factors, but I certainly think the idea of operating within Windows and having these occasional hiccups with programs and with games in particular. That seems like kind of a bit of an annoyance relative to just having an x86 processor that you know is going to work, or at least as well as things work under Windows. Sometimes things will work at least as well as they are expected to, basically. So yeah, I kind of do wonder about that. Another thing I wonder about a little bit, just kind of idly here, is if that impacts ARC at all, if that impacts NVIDIA's plans with ARM at all, potentially. I think that maybe ARC, being a business that, as far as I'm aware, is losing money within Intel is not necessarily doing so well there. Would this kind of put some pressure on that effort, because all of a sudden Intel does not need to go to some internal team to have a good graphics architecture for their products? Potentially, they could just use a multi-chip solution with an NVIDIA graphics processing unit. So I think that's potentially one point of pressure. I'd think that on the NVIDIA side, I'm pretty sure they're going to go ahead with ARM for their own reasons, and I think that's an interesting kind of speculative product at least for the consumer set of customers there. But yeah, I'm not exactly sure where that will go, but I would tend to think that it might put some pressure on some existing plans within NVIDIA and Intel there.
Mm-hmm. Yeah, I think we've got to sort of stress that it isn't two companies coming together to to create one mega company. It is a collaboration. It is a partnership, albeit a historic collaboration, quote unquote, according to Jensen Huang. So, but even so, I still don't quite figure out the economics of it, because I'm sure NVIDIA would rather make all of the profit on a laptop processor as opposed to, sharing some of it with Intel.
Yeah.
And they can't actually acquire Intel. I think the cross-licensing arrangements on x86/x64 with AMD would essentially prohibit that license being transferred over. So, there's only so much that NVIDIA can actually do in partnering with Intel. It certainly can't acquire them. And of course, the fact that this is just a newly inked deal means that product development kind of like starts now. And we all know how long it takes to actually create a piece of silicon. The answer is years. So in the short term, I think ARC is going to stick about. I think, Intel's still going to need to actually up its game in the GPU space, unless it wants to rely entirely on this partnership, which I'm not sure is a great idea. And of course, NVIDIA is still going to be producing their ARM-based SoCs in the short term. I mean, the work's done, as far as I'm aware. Those products are coming soon. But certainly really exciting to just think about all of the opportunities here and what it could mean in terms of products and in terms of gaming. And fascinating stuff. We just didn't expect this at all. But here we are. Okay, let's move on to our next news topic. Okay, so we've got to talk about this. Essentially, it is now possible to run FSR4, AMD's next generation machine learning based upscaler, on older GPU architectures and indeed on NVIDIA architectures, if what I'm reading here is correct. Essentially, there was some kind of rogue source code leak from AMD itself that included the ability to compile a DLL for FSR4 that would run on older AMD architectures. The way it's been done is essentially that it's using INT8 machine learning based instructions, which are supported on RDNA 2 upwards, I believe, and of course is supported by NVIDIA. And somebody's put together a DLL, and it's remarkably easy to actually introduce FSR4 for those other pieces of hardware simply by, well, for native FSR4 games, it's really straightforward. You just copy a few DLLs across and do a bit of renaming. And it's just kind of remarkable stuff. Now, we have got some performance numbers here. I did actually do some testing here. But this is still very much work in progress, I would say, in terms of what it is we're actually dealing with here. There's a lot of unknowns. Let's do some benchmarking, though. I chose the 7700 XT 12 gigabyte VRAM card there. The reason I chose that is because there are concerns that an INT8 version of FSR4 has significant performance penalties, and I didn't want to sort of blast past those restrictions by using something like a 7900 XTX. So let's take a look at Cyberpunk 2077 here. It's actually a comparison of the high setting running at 1800p resolution, no ray tracing, yes, native result there on the left, 57.95 FPS average. Now, here we are comparing XESS. I believe this is 2.0, so we've had to actually change the quality level from balance to quality. 27.6% advantage over native. FSR4, though, actually faster, 34% faster than native. FSR3, though, faster still, 44% to the better against native. FSR3, basically an 8% advantage over FSR4, with FSR4 having 92% of FSR3 performance. So here's the thing, right? And there are a lot of question marks. And Alex, I'm curious what you think about this. We'll talk about some other benchmarks shortly. But let's say we've got a fully armed and operational version of FSR4 upscaling here that is capable of running really nicely on older RDNA 3 GPUs, possibly RDNA 2. We've not tested that yet. And the performance hit isn't actually that huge and is actually better than XESS. I guess there are questions here about why it only exists in this form and why it wasn't ever given a rollout. My guess is that AMD basically wanted to focus on one product and to get it out there and to iterate on that and go from there. But there is obviously a lot of interest in an INT8 version of FSR4 because, well, at some point there's going to be an INT8 version of FSR4 that is the next generation version of PSSR for PS5 Pro. So what's your take on all of this?
Yeah, I mean, I think it's kind of an NVIDIA-like move there, where I think NVIDIA has released technologies in the past, especially the most recent past, where I'm pretty sure they would run on the previous generation to some degree. For example, I really think FrameGen's newest multi-FrameGen mode, based upon the differences between Ada Lovelace and Blackwell, should at least be capable of running on something like a 4080 or a 4090 with great ease. Because if we see it running on 5060s, which have far less compute and far less machine learning capabilities than a 4090 or 4080, then I don't see why it could also not run those things. And I kind of feel like it's slightly different here because there is actually a great difference in machine learning capabilities between RDNA 4 GPUs and RDNA 3 GPUs. But the fact that they already had this version in there, in the source code that they accidentally released, tells me that they were definitely thinking about it and were working on it. And the reason's probably, like you suggest, that they really just wanted to focus on promoting and getting the version of FSR4 for RDNA 4 out in a good way. And it came out in an incredibly good way. We pretty much only had positive things to say about it. The only thing that was slightly negative about it was it did have a slightly higher performance cost than the equivalent DLSS 3 or 4 settings relative to like output resolution and things like that. And here it would just be, once again, proportionally heavier again. But based upon your performance metrics there, even on a not top end RDNA 3 GPU, it seems rather reasonable. Yeah. And then I think that's all great. I just do slightly wonder why they didn't, just like you, I do wonder a little bit why they didn't think about at least putting forward more public statements about whether it has a future or not. Because currently I think it's a bit unknown whether this will ever come out at all.
Well, there is going to be an INT8 version of FSR4 called Next Generation PSSR. And I do think strategically it makes a lot of sense for AMD to backport FSR4 to older architectures, specifically for handheld. We've seen some testing this week from other outlets which have, basically got this running on a Steam Deck. And they are talking about a computational cost, a hit to frame rate, but it does seem to be borne out by higher quality visuals. I'm going to talk about some other benchmarks, which I did because obviously every single game that implements an upscaler has a different performance increase based on how that upscaler is implemented, and obviously the content of the game itself. Monster Hunter Wilds. Let's have a look at this one then on the 7700 XT. This is high settings, high RT, 1440p resolution, native resolution, result 53 FPS essentially, 24% boost on XeSS. However, only 21.5% on this new FSR4 injection method. FSR3, mind you, 37.7% performance improvement, which is kind of like what you'd kind of expect, really. This is using balanced upscaling, which is kind of quality on XeSS based on the way they've essentially renamed things there. So in this case, FSR3 is like 13.3% faster than FSR4, meaning FSR4 has 88.3% of FSR3 performance. It kind of changes there. I'd still say, though, that it's worth doing, right? Especially if the image quality improvements are there. And obviously, there's the possibility of anti-aliasing improvements there. Let's talk about Miles Morales, Spider-Man game, which I found to be acting in a rather weird way. 4K settings, RT optimized here. Native resolution, 44.89 frames per second, but look at those frame times. Man, that's gnarly. I'm kind of wondering whether running natively here is actually hitting the 12 gigabyte limit of the 7700 XT. But when we use upscaling, frame times behave a lot better. A 48% increase with XeSS, 55% with FSR4. But here's the weird thing: FSR3 and indeed ITGI, the Insomniac upscaling solution, it's basically a doubling of performance here. It's way ahead of the other upscalers there. Could be a bug in Miles Morales there, but regardless, slightly strange results there all around. There's outstanding questions though, isn't there, Alex?
Yeah.
Specifically, and you put this to me quite succinctly, the maths has changed. By moving from, I think it's FP8 that the standard FSR4 uses, right? By moving to INT8, obviously things have changed. There's also, the question of whether this is actually anything like the most modern version of FSR4 that AMD actually put out. So I think we need to do some image quality comparisons to actually figure out whether this is, actually in any way worthwhile data at all.
Yeah, I mean, based upon what I've seen and a couple of comparison screenshots, and this is no surprise to anyone, it's better looking than FSR3.
Right.
I don't think it's very hard to get better. Well, it is hard enough, but improving on the areas where FSR3 fails is a great boon to things all over the place. That's why we love FSR4. And we've seen already improvements there. So it is at least better than that. But the question is, would it be the exact same as bog standard FSR4? And I would probably contend it will be different. In some ways, it's kind of also by the reason that I think Mark Cerny is reluctant to call the next version of PSSR, FSR4 just on console. He's like, no, it's like a collaboration. It's FSR4 maybe infused or something like that. And I think otherwise, the reason why I'd say otherwise is because if it was the same quality and with the same constraints and same weighting and all that, we would see what we kind of see when you run the transformer model on lower end, older Ampere and Turing GPUs on the Nvidia side, especially for something like ray reconstruction, where the hit to performance is quite a lot greater on those GPUs. So that's why I think it won't actually be the same quality in all cases. I think maybe for basic cases, it could be very similar. But as soon as you start stressing the model more with like different content and different problem areas, I think it could actually end up showing different image quality. But that is my speculation at the moment. I think we actually probably should do a image quality analysis of some sort in the near future.
Absolutely, yeah. I'm curious what you think about all of this, Oliver.
I think it's a very compelling option, potentially, especially for those RDNA 3 GPUs. I know that AMD was talking about porting FSR4 for RDNA 3, and it seems like something that would be imminently doable, or at least kind of in the range of something that's as doable as like DP4A XeSS, something that could enhance image quality meaningfully on that hardware. But I was kind of thinking, kind of spitballing about this, for consoles, because we do know that Microsoft pursued some kind of ML-based upscaling for Xbox Series machines early on. In like 2020 or 2021, they were showing off some machine learning based upscaler, some relatively primitive one running an Xbox hardware. But I kind of expect that like even on that class of hardware, which does have INT8 acceleration, the RDNA 2 based Xbox hardware, notably not on the PlayStation side, at least with the PlayStation 5 base console, not with, obviously with the PS5 Pro, it's a different story. But I think that in that case, you're looking at, again, some questions about the quality of that acceleration, some questions about if it would actually be performant enough within a reasonable amount of frame time for reasonable upscale targets with reasonable internal resolutions relative to other solutions, relative to a TAU, certainly relative to FSR2 and 3, which have become kind of the default multi-cross-engine upscaler of choice this generation for the consoles. I think there'd be some serious questions about whether that's reasonably feasible. And then, of course, producing a neural network of this quality, producing something that can actually, beat FSR2 and FSR3 in different scenarios across different kinds of image quality challenges, I think is very challenging. Like we've already seen, with PSSR, even that when you have, a firm like Sony trying their hand at this, it isn't necessarily always beating those other solutions, or at least initially did not beat those other solutions across different kinds of image upscaling scenarios and different kinds of games. So I would be, certainly interested. Like I know people talk about like the, 97 int for tops or whatever on Series X, but I think realistically, this probably is not something that's going to be suitable for the level of machine learning acceleration that's in the current generation consoles. I'd venture that, any kind of solution like this would only really be suitable for the PlayStation 5 Pro, or obviously next generation console machines. I don't think it would be great for last generation hardware.
Yeah, I did want to do more testing, but my test PC stopped working. But what I did do was to basically go back to Cyberpunk 2077 with this injected form of FSR4. And yes, the RX 7700 XT, 1440p output resolution, balanced mode, and essentially our settings are equivalent to the PlayStation 5 performance mode, but I've added in Alex's optimized RT settings, which are essentially reflections on and lighting at medium, ray-traced lighting at medium. That gives you kind of like the headline RT features, so to speak. It's not nowhere near maxed out, but it is a really nice looking ray-traced experience. Kicking off with balance mode. This is VRR here, which I think is kind of like, it's still topping out at 60, but it dips into the 50s. But I think the question is really, Alex, the quality of the output. I think it looks okay, bearing in mind that FSR3 balance mode at 1440p resolution has got more issues than Top Gear magazine.
Yes. I think the reason why this could be worth it, depending upon your, I would say like the overall GPU compute experience, like how much you have in total. Like I think as you get lower down, like Oliver was talking about, it becomes less useful because you're sacrificing potentially a lot of frame time to get this feature on. But I think the one thing that it has a major benefit for is like you're describing, where you're at 1440p, 1080p, and really those are resolutions that we've typically not really liked FSR 223's output on them, where it gets better. Basically, it gets pretty darn great, at least like, maybe above balanced mode in 4K. That's like really where we've seen it excelling. And here, it just becomes, you can actually do other things at those resolutions now. You can actually push things that you otherwise wouldn't have before, in spite of it being a little bit heavier. But, this is kind of what XeSS has been for a lot of RDNA 2 and RDNA 3 users. But now if this became a more official option, then it would be, I don't know, most likely preferable.
Yeah. Looking at the footage there, I actually went from FSR4 balanced to FSR4 performance. And there's an issue kind of like on our sort of internal time codes here about 350, where you can see what looks like, well, it's sort of definitely the case that AMD needs ray reconstruction of some description at some point, because the shimmering on the puddle there, it is ray traced, but it's quite ugly, right?
Control. Yeah, it's not the greatest, no.
But, that aside, even the FSR4 performance at 1440p, which will be internal 720p, I don't think it looks unattractive apart from those sort of more obvious artifacts. So I think, there's two ways we can look at this. I think at some point there probably is going to be some sort of backport of FSR4 for older architectures. And I think handheld may well be one of the most, biggest driving factors for that, because I don't think we're going to be seeing RDNA 4 in handhelds. So, and obviously those handhelds do need a good upscaler, I think it's fair to say at this point. And obviously there is the PSSR stuff going on, which again is going to be INT8 based in nature. But all I can say is I'm kind of quite happy from a certain point of view that we've actually got this leak, that we can actually do some testing. We can actually get some idea of how FSR4 would look on those older architectures. Obviously, I don't think AMD is going to be making any kind of statements about this or providing any kind of information about it because, ultimately it wasn't supposed to leak, was it?
No.
But it's certainly a fascinating sort of one of the most fascinating leaks that I just sort of had to take a look at that and see how it all panned out. And I do suspect that a lot of people are going to be injecting this into future FSR4 native games because it is just a really simple case of just swapping over some DLLs. And I understand that FSR 3.1 games that don't have native FSR4 support, you can use Optiscaler to inject this DLL. So, there's a lot of opportunity for people to actually get a really good machine learning based upscaler out there, even if it's not in any way officially supported, but a fascinating revelation nonetheless. But with that, I guess we should move on. Okay, so we had to talk about this. Last week we talked about Borderlands 4 PC performance based on launch code, and I think it's fair to say that there are a lot of problems, foundational issues, Unreal Engine 5 based issues rearing their ugly heads again. And, well, what can I say? The Gearbox's CEO, Randy Pitchford, has taken to social media to essentially, I don't really quite know how to describe this, to push back, I think would be a good way of saying it, against some of the narrative that's emerged here about the quality of the PC version of the game, and also rather bizarrely to offer individual technical support to, to certain players. This is kind of bizarre, but it's certainly kicked up a lot of controversy on the internet, and I guess we're going to talk about it as well. Oliver, what do you think about all of this?
Yeah, I think when you have a game that launches in a bad state with performance issues that are like really difficult to address and kind of profound, like obviously on the consoles you have this horrible memory leak. On PC you have this strange shader behavior with like lots of stutter, and then also like this DX caching issue that people are reporting, increasing the size of their shader cache like 100 gigabytes because they're getting like 10 plus gigabytes of cache shaders over time, which is kind of insane. I don't know where that's coming from necessarily. Lots of traversal stutters as well, or at least some traversal stutters, and generally poor performance for the kind of visual return, I would say, as Alex pointed out last week. I don't think that's stuff that you can fix just by kind of insisting that the game runs well or yelling at people. It's also not something that you can fix if, like Randy, you suggest that if people are upset, they try to develop their own game engine instead as kind of a rejoinder. But yeah, I think his approach to customer service has not been good, and I've documented a few of his unique approaches to customer service. So I have a couple tweets here, but he recommended extreme use of FrameGen, 4 times FrameGen to recover performance in an RTX 5080. He claimed in another tweet the game is pretty damn optimal. He said that the issues in question affect a very, very small percentage of users. And then in another tweet, he claimed that PC performance complaints represent 0.009% of valid customer service tickets, which I just don't see how that could possibly be true, And then he says that gamers with 2 or 3 year old PC hardware should lower their expectations, which I also don't really understand, especially given the context of like modern PC hardware, where 2-year-old hardware, that's could be like an RTX 4090. It's just not really in concordance with the way that PC hardware behaves nowadays. So I think that Borderlands 4 hits kind of a confluence of kind of overlapping issues. In UE5, there are some issues with maybe users turning up their settings to the max, and I certainly sympathize with Randy a little bit, at least, when he says, turn down the game from epic settings, because epic settings is maybe not helping out so much, because obviously, that's kind of a placebo setting to some large degree in Unreal Engine 5 games often, especially with Software Lumen. Software Lumen has the same issues regardless of whatever preset you set it to, generally speaking. But this is a game where no amount of tweaking, no amount of user side fixes, no amount of Randy Pitchford telling you exactly what to do can fix its issues on different platforms. And I just think the smarter customer service approach is almost invariably to say, hey, we're working on this. Don't worry about it. We'll have a fix for you. Or at least we're looking into it, and not to just kind of spin out and address everyone in your comments, everyone who's putting you in their mentions on Twitter. That's always a mistake in my view when dealing with these kinds of problems.
Yeah, I agree entirely. It's basically like logo up top, black background, white text saying, yes, we understand your concerns and we're looking into it. We'll keep you updated with our progress, and then move on to actually fixing the problem, as opposed to kind of suggesting that it's not a problem, or that PC users have got issues or whatever. Alex, thoughts?
Well, I'm tempted to I told Oliver this. I said I'm really tempted to actually try and see how big the shader compiled shader cache ends up getting in a game like this, but that would mean subjecting myself to multiple hours of Borderlands 4.
Well, 100 gigabytes shader cache, Alex, I venture to suggest that is somewhat extreme, and I don't know whether it's one of these
placebo,
one of these placebo fixes of which there are many.
So I thought about this, and I even spitballed it with Oliver. I thought, technically this game, I don't know exactly. Nvidia changed it not too long ago. I believe the default shader cache for the longest time was about 4 gigabytes, and it may be larger now. I'm not actually certain. I'm pretty sure NVIDIA did change it most recently. But if you use, you can change that to a variety of settings in the NVIDIA app, I believe, as well as NVIDIA's control panel. But there is the case where it could end up being problematic on a system that has been playing a lot of games, and the shader cache is already a certain size, right? And then it's going to roll over as soon as you hit 4 gigabytes or whatever the limit is. So you've been playing a lot of games that have a lot of shader variants, and you load up another game that has a ton of shader variants, and it just keeps rolling over that max limit. And so you keep having more just-in-time shader compilation because the driver is culling the ones already on disk or something like that. If you developed your game to have 100 billion different shader combinations without any thought to what it would be like on PC, well, then the problem is a little bit on you too. So, I've got very strong opinions on this, and I disagree with Randy.
Okay. Let's take a couple of supporter questions. This one from Yinj. Good day, humans. I have a question about shader pre-compilation sparked by Borderlands 4. Is shader pre-comp black magic, or why is it so difficult for developers to have a complete set? Is it like a checklist you have to go through and mark, or how does it work? Is it just quote-unquote lazy devs, or is QA, if they still exist, the problem? Cheers.
Wow.
Alex.
I would never say the phrase lazy devs ever, unless there was some really just like a video of a developer hitting upload to Steam after they just started a project or something. I have no idea. I don't think I would ever use that phrase ever. People work a lot on this. I think there's a lot of bad management decisions at times, but that's about it. But in regards to the problem, certain engines like Unreal allow artists to just randomly, wantonly, without much care in the world, create a whole bunch of different shader combinations. And that is just the base shader combination for a certain graphical quality level, and it may explode as soon as there's more graphical quality levels available to the user, which the engine provides. And in a case like this, Unreal is definitely that type of engine. And if you're starting a project, you have to probably right at the genesis or at the middle point of the project say, how do we rein this in to make it better? And I think that is a project specific problem, that you shouldn't be just creating 100 million different shader combinations because you can. At some point, it doesn't matter anymore. Like, you're not getting a great difference in the art visual quality by having a bunch of combinations. I mean, when you look at something like Doom: The Dark Ages, does it look dramatically worse with its small amount of shaders than something like Borderlands 4? I would contend it doesn't, right? So I think that's an issue. Another issue is actually the gathering process for shaders. Unreal still has this issue where it requires a manual gather of the PSO bundle that you will be shipping with the game, that will be precompiled at whatever point the developer decides to precompile it. And that manual gather process is still 100% a manual gather process, as far as I understand it. And, you know, there's automated ones that like do global shaders, I believe, but it won't do game specific ones. And in which case, yeah, it is actually, it's not a QA problem. It's not their fault, but it becomes an issue of like QA needing to play the game shortly before launch with all the shaders, unless you come up with some sort of automated system. And I don't think the engine is doing that right now. And that's another area probably where there should be more iteration in the industry in total to make this problem less endemic to games, especially Unreal ones. Okay, so it is a big issue. Yeah,
it is the case, though, that in a lot of your videos, you're talking about a shader compilation burn that doesn't catch all the shaders. And that seems to be not great practice, right?
Yeah, it's also just really annoying, too, because it's like, I'd understand it if you're like 5 hours into a game and you open up a random chest or something like that, you know, just like some like semi-hidden, not common area of the game. I'm not going to break a developer in a video for that. But like in Borderlands, it was just like, I'm pretty sure all I did, I don't even recall if I even changed the graphical settings after it loaded up. I don't think I did. It was already set to badass or whatever. But they were like immediately available with like visible within the first 5 minutes of real gameplay. And that's where I feel like there's a big disconnect, where I'm not sure always if the priority of developers is the same as mine, where I say at least have a really good first impression. Games can get technically a bit worse later on. And I think it's a bit more reasonable, but at least have that core experience in the beginning be very polished. Borderlands fails there. So, yeah.
Okay, fair enough. We got this question here from Cress Kowalty. Greetings, founders! ! Is Borderlands 4 performance as good as the internet would make you believe? Or as bad as the internet would make you believe? Randy Pitchford is doing a terrible job with communicating, but is he a tiny % right? A gamer's too stubborn with refusing to use upscaling and expect games to run great maxed out. Shouldn't the conversation be more about game optimization versus finding the best settings for your quote-unquote gaming rig? I think this is probably an interesting point to make, but probably not with regards to Borderlands 4. Because we're finding, Alex, especially with Unreal Engine 5 games, that if you include the epic setting within your menu, chances are you're basically massively impacting your performance for very little visual gain. And it's to the point now where certain titles, for example, Star Wars Outlaws, Avatar Frontiers of Pandora, actually put the maxed out settings behind a launch parameter to specifically lock you out of just maxing everything out and then complaining about poor performance. So to what extent is this correct, and to what extent is this incorrect for Borderlands 4 specifically?
Well, I think it is a shame that we're talking about it within the Borderlands 4 discussion, because I think the game has issues regardless. But I think in general, no one should ever max out a game and then start complaining. I think you need to first see what you can do in the settings to improve the experience. And that is where that's the area where, for me, I'm pretty sure Borderlands, like many Unreal Engine, I haven't done it, but I know Hardware Unbox made a video about optimized settings for the game, and they found great wins very easily, like in a lot of Unreal Engine games, just by turning things down by like 1 or 2 levels, right? And that is actually a big way to win and not sacrifice too much in terms of visuals. And I think that's something every PC player should be used to at this point. And I don't think you should ever knock up a game to Epic, Ultra, whatever. From a UX perspective of developers, though, I think they should. I mean, I do kind of like the solution that Massive has with their Snowdrop titles, where they do lock it out. It's kind of like we let the power users actually, and turn on those settings. They even have a name for it. It's not like you turn it on with a launch parameter and it just like runs, but there's actually new settings in the menu, and it's pretty cool. It's really nice. But I think maybe everyone should take the route of what's the name of the developer who made Kingdom Come Deliverance? Warhorse, where there is a setting at the top, but as soon as you select it, the game makes it immediately apparent that you are doing something that is going to negatively affect the experience. There's like a warning menu. It has a name that is scary, experimental. Like, it doesn't sound good. Should I be even touching this? It's radioactive. And I think that is maybe my favorite way to do it, just because it doesn't have like the ability that you have to like learn about this online or something separately out of the game. It's still in game, but it makes it immediately apparent that the standard user should just be using the settings below it. So I like that. I don't know. What do you think, Oliver?
I think there probably is a conversation to be had about the utility of like Epic settings presets or their equivalents or unobtainiums or whatnot in games, especially exposed as default, when they're exposed as default, because they don't necessarily contribute much to the visuals often. And especially in this age of VRR, I feel like that additional margin of performance can really benefit people in a way that it maybe didn't when everyone was trying to hit 30 FPS, 60 FPS, whatever, fixed. Now people are going for, ultra high refresh, unlocked experiences, and I feel like it benefits people a lot more in that context. But I also do feel like things are being scrambled a little bit when you have a 5090 or 5080, and it's still probably not a good idea to use Epic settings or use native res rendering. Like, I feel like that just scrambles people's brains a little bit. I do think like temporal upsampling at least should be considered standard these days, especially with like UE5, where a lot of the lighting detail is scaling based on pixel count, and so it gets very punishing to run at native resolutions. But I do tend to think that people maybe, either one of two things needs to happen, right? Either the industry needs to change and do things, and some developers have also, like when you look at a title like Hellblade 2, I believe on PC, when that game shipped, it just exposed low, medium, and high, right? So that's a developer, at least initially, that's a developer that was saying, hey, we don't think you're actually going to see much of a benefit above high, and we don't want you to use it. Or alternatively, people need to come with the knowledge into games that when you select that high settings preset, in many game engines, that's very often a placebo setting. It's not going to be a benefit to you. And also, you should not use native rendering just as a general rule with modern games that are more demanding.
Yeah, that is such a good point. Sorry, Oliver's very right in the fact that I think the expectation of native resolution rendering, when you look at how game graphics are being made these days, especially on Unreal Engine 5, is maybe not an appropriate expectation. It's an appropriate expectation maybe for something like your Counter-Strike 2s, whatever your free-to-play game is. But I don't think it is in the context of modern AAA very appropriate, because a lot of effects, and it's been this way actually since pixel shaders became bigger. Like, a lot of effects scale with resolution in a way that is detrimental to performance as you start ramping up resolution, right? So, and Unreal Engine 5 is just even more so this. It's not just screen effects, it's geometry, it's every, VSMs, virtual shadow maps, get more expensive the higher res they are. They're not a fixed cost. They're based upon what your screen resolution is. So all these things get so much more expensive. And as soon as you realize that as a user, then you should probably not be expecting native resolution rendering. And with things like DLSS4 or FSR4, I really don't think you're getting a lot from native resolution anyway these days, especially after you look after quality mode and all those things. Like, I was just showing Dying Light the Beast running with DLSS 4 quality mode. I could have easily ran it in DLAA and it would run like, but I think I'd rather have like a ultra high refresh rate experience, right? And that cancels it out in a way that Oliver mentioned. So I think, but maybe there should be some sort of menu, once again, a warning saying like native resolution rendering will not bring you great visual quality increases. Are you sure you want to turn this on? Like when you turn on DLA or TSR native, maybe that's another thing that needs to be in the UX toolbox of a lot of developers, because judging a game by 4K native is super counterproductive.
I just think a sort of final point from me is fairly straightforward. Every developer that is producing a multi-platform project has optimized settings for their game, and they deploy them on the PlayStation 5 version. Just put those settings in as the standard defaults. And then maybe if you wanted to go a bit further than that, then, basically change the resolution according, or the upscaling factor according to the class of card that is within the PC. And that should get you most of the way there for a lot of games. Obviously, when you're sort of talking about handhelds and people sticking to their GTX 1060s, it's a completely different ball game. But at least then, you have got at least an idea of what fades the developers were willing to make for their console versions, which so often now is becoming optimized settings when we take a look at it. So that's my thoughts on that. But let's move on. A final news topic of the week, and pricing has started to emerge for GPD Win 5, which is looking to be the first handheld system to use the Strix Halo APU. Strix Halo, we looked at it recently on Digital Foundry within a mini PC, and suffice it to say that it's a highly capable piece of kit. This is going to be a next generation handheld beyond compare, and it's going to cost a lot of money, as you might expect for an SoC that's like, significantly larger than the PlayStation 5 Pro SoC on the same process node. China pricing has cropped up, and it's looking to be like a maximum of $1,800.
Oh my goodness!
On the pre-sale price. For the 64 gigabyte version of the GPD Win 5 with the Ryzen AI Max Plus 395, which is the best of the best. The 2 terabyte model, it's looking like $1,400, and the AI Max 385 with a 32 gigs of VRAM, that's coming in at about $1,200. The difference there seems to be like you're losing 8 of the compute units from the SoC die there. Oliver, you're our resident handheld specialist. You must be fascinated by how this is all going to come to pass, because I kind of still can't get my head around the fact that people are going to be putting this gigantic SoC within a handheld and expect it to work. But, these guys do know what they're doing.
Yes. Well, certainly based on your testing, it seems like there's kind of a range of TDPs potentially, possibly in that kind of like 45 to 60 watt range, which are kind of cognizably appropriate, at least for some class of handheld, where this chip really sings. I think you're seeing it like operate within a pretty good percentage of something like an NVIDIA, 4060 desktop chip, those kinds of, that kind of class of kind of lower end, mid-range, and whatever laptop and desktop hardware. So it does seem like it works, at least if you can fit it physically within your system. I think the total package is like 400 millimeters squared or something. It's pretty huge.
Yeah, it's huge. Bearing in mind, PS5 Pro is like 280 millimeters square.
PS5 Pro is a lot smaller than this. Console designs are typically smaller than this chip. So it's certainly, well, it's a multiple chip package, obviously. But yeah, I think this is, it's expensive, but this is like a premium device. It's not a mainstream PC handheld. And there are like no cheap Strix Halo devices. Like the Framework desktop, I was looking it up, with 64 gigs of RAM and an AMX Plus 395 or whatever, the top end Strix Halo is $1,600 US. The ROG Flow device starts at $2,100 US, and that's with the, I think, 385 or 390 chip, not even the top 395 chip.
Right, okay.
I think AMD is setting a pretty high price floor with these products, just through their own pricing for the Strix Halo package and associated tech there. Because if you look at the Framework site, just the main board for a 395 system with 64 gigabytes of RAM is $1,300. So you presume there's some margin for AMD in there, there's some margin for framework in there, but it's still like a very high price. And, this is like also, it's worth reiterating, like this is a large complex chip. It's composed of 3 main dies. It has a 256-bit memory interface. This is all expensive to route and whatnot. And AMD is also the only player offering a chip like this, offering a design like this. So when we talk about AMD, rather when we talk about Nvidia and Intel potentially kind of entering a similar space with their products, part of the appeal there is we're going to see a little bit more competition for these like larger graphics die products that could potentially fit in low power envelopes there for PC laptops and handhelds. But I do think this price can be justified, especially in a world where you look at something like the Asus ROG Ally Xbox ROG. I always screw that name up, which is something.
Is hard.
It's hard. I always forget the order. But anyways, where the Xbox Ally is something like $900 US for a Z2 Extreme, like this product, well, or at least it's supposed to be $900 US. They've not actually announced an official price owing to, I think, tariff concerns. So it's like, I think it's launching in 3 weeks. They haven't done pre-orders or an official price, which is pretty nuts. That's obviously got to change very shortly, I would hope. But this is like, $1,600, $1,400, something in that range. A little higher if you want the max specification, which is kind of ridiculous with the 4 terabytes of storage and whatnot. For a device that will outperform that chip by a large margin at, reasonably high TDPs here, I think that's a reasonable offering, especially if this device comes in and it has a good fit and finish, works well, there are no glitches or issues with the external battery pack, and it seems reliable, it seems like a durable product, it seems like a high quality product. I think you're getting your money's worth basically for that additional performance, because the Z2 Extreme, the Strix Point, is not really a close match for Strix Halo in any respect, unless you're really tamping down that wattage, like 15 watts, maybe 20 watts, then there it's more competitive. But 30 watts, 40 watts, 50 watts, if you really want to stretch that chip, it's not going to be able to hold a candle to Strix Halo, I couldn't imagine.
Yeah, there was a part of the video that I kind of kept quite short because it would be actually really easy to use that mini PC to kind of emulate the kind of specs that that's being mooted for these handhelds, right? But there is this one clip that I want to show you where it's essentially Alan Wake 2's PS5 performance mode settings scaled down to 1080p resolution using FSR4 quality mode. So it's essentially upscaling from 720p to 1080p. 1080p is the screen that's being used for this. And 54 watts, you're basically running at exactly the same performance level as the console. Basically you've traded a reduction in power for a reduction in resolution. When you sort of cut to the bone and go down to 30 watts, you're going from like mid 50s down to like mid 30s, which doesn't sound great, but then you're essentially getting what's very, very similar to Xbox Series S performance in what is a very demanding game. And this scene is like one of the most demanding in the entire game. Mm-hmm. So, there's a lot of sort of reasons to be like very optimistic about Strix Halo handhelds, because, a lot of the trades that you have to make on like Strix Point and Steam Deck and Z1 Extreme, et cetera, you kind of just don't need to make here. And it's liberating, but it's also kind of, you sort of wonder what you're going to do with this surfeit of GPU power. But it's just really, really cool. And I'm really looking forward to seeing how these things actually work from a practical standpoint, because, I think it's like 440 square millimeter die there, counting in all of those chiplets on there. So it is kind of nuts there, but I'm really looking forward to checking it out. It is going to be expensive, but beyond the kind of mainstream devices put out by Lenovo and Asus, these devices have always been expensive from the Chinese manufacturers, and this is no exception. So I'm expecting, probably the US prices to be even higher than what's being mooted here. But it is a very, very sort of niche market, I'd say. It's kind of almost the sort of thing where, they're doing it because they can do it, not necessarily whether it's actually a great idea for a product that's going to sell a lot of units. I'm also sort of interested to see the difference between the AI Max 395 and the AI Max 3 is it the 90 or the 380 that's got the 8 fewer compute units?
I think 385 is the one with 8 CPU cores, so just the one die there, and then I think 32 CUs in the GPU.
Yeah,
I'm pretty sure that with gaming, the two CCDs, one of them is basically deactivated anyway. I think that's what the forks was saying about that, which makes perfect sense because not many games actually need more than 8 cores and 16 threads. And there's obvious power saving sort of advantages to doing so. Alex, thoughts?
Well, I keep thinking like this thing is overspec'd in a lot of ways.
Yes.
And I always wondered, like, what is preventing AMD from making some sort of mid-range APU? Why does it need to just go from like ultra low to like this thing? Like, I was watching your video and I was just like, why does it have so much RAM? I was like,
well,
why
because
does
it's
it have
aimed
so
at the
much
AI
RAM?
market specifically.
Okay.
Where that kind of makes sense, doesn't it? I mean, Oliver, you looked at the Mac Studio, which is actually no, AMD isn't really positioning it against. They are positioning it against M4 Pro for AI purposes, which is kind of like Mac Studio territory, but not mega high-end Mac Studio territory.
No, I don't think they can reasonably compete against like the Apple Ultra chips. Actually, maybe my M1 Ultra, which is now a 3-year-old computer, also has 120 gigabytes of RAM, has a 20-core CPU, but 4 efficiency cores, so 16 performance cores versus the 16 kind of high-end Zen cores on the Strix Halo device with the 395 Plus Max processor, or whatever it's called. That's probably a pretty close matchup, I'd venture to say, in a lot of respects there. I think part of the reason why they probably don't have a mid-range chip is just the lack of product market fit there. Because you look at these devices, and we're talking about scaling this gigantic chip down to a handheld. There's probably not a huge market, I would venture, for like handheld exclusive chips that might straddle the difference between a Strix Point and a Strix Halo. I think that would probably be the provenance of, a very specialty chip. I don't think that would move massive numbers. I think the Strix Point chip is something that AMD is comfortable with addressing that market. I don't think they're really interested in developing specific products to fit that market. Maybe something like the Intel Nvidia thing, you could see a bit of a mix and matching kind of chiplet approach. Maybe next generation with AMD, we actually might see something like that with RDNA 5. Apparently that's in the works for a successor device to Strix Halo. But I don't think that's in the cards for now. But certainly at 30 watts, Series S performance, you got a 1080p panel. That sounds like a match made in heaven. That sounds perfect to me. I mean, who could be upset with that? Providing you can provide the appropriate cooling and get that all sorted internally and have okay battery life. Maybe you will have okay battery life. Maybe you won't have room for a battery. Who knows? But maybe that would be. Well, in this case, you don't have room for
it's
battery.
A battery pack.
It's a battery pack. But I think that could be cool because 1080p display, Series S is a perfect marriage in my opinion.
Yeah, I mean, I think they actually target 1440p for Alan Wake on Series S, but with like 800, circa 847p, I think maybe for
847.
resolution on that.
Sounds familiar. Yeah.
So but it's it's ballpark here, and obviously these devices are outputting to 1080p screens, not to something that's got to kind of look good on a 4K living room display. Interesting nonetheless, and I really do want to check that out. But I guess we just need to wait for these devices to actually manifest. But with that, let's move on. Okay, let's move on to supporter Q&A, which is the part of the show where every week we ask our Patreon supporters to pose their questions. We choose the ones we're best equipped to answer, and here they are. We're going to kick off with this one from Cotton Bird. Have you explained what virtual shadow maps are? Most of the explanations I've found seem to be for people already making games in Unreal Engine 5. It seems like it's nanite, but for shadows. Is there anything markedly different between VSMs and other shadow techniques in terms of the end result seen by the player? Good reason to come up with a quick explainer there, Alex, I think.
Yeah, so you can think of them as, if you recall what mega textures was like back in the day, where essentially you'd split up a texture into many pages, and you load in the relevant ones of a certain resolution based upon the screen space size of relevant texture from your position. And that would save on memory, because instead of loading in a whole texture, you're loading up a smaller part of it, and it's still going to look high res enough because it's only occupying a certain percentage of the screen. And as the closer you get, the more larger pages, etc., of that specific texture are loaded in. You're dramatically decreasing the amount of texture memory you need to show high quality textures. Nanite follows a similar path, but it's focusing on geometry. For virtual shadow maps, it's a similar path, but it's the shadow map resolution. So you can just imagine those pages as being like bits of a shadow map. And in VSM's case, so that would give you like a super, if you just did it as is, in the way like VSM's is virtualized, so that means you're just getting really per pixel perfect shadows on most things. If you did that, you just get really hard shadows everywhere. So they came up with another technique on top of it. The Oliver in the past is called, I think, like shadow map tracing.
Ray tracing, SMRT.
Yeah, SMRT, shadow map ray tracing or something like that. And basically you can imagine it as like a filter. It's not actually filter, but you can imagine it as a filter, that makes it so that shadows that have an occluder close to them have a more diffuse look. So, they get further away, they get more diffuse. And as the closer or the less parallax there is between the two objects, the shadow starts to get sharper. And this mimics the effect in real life where the base of an object that is shadowed near a casting light will be sharp, and then further away, it'll get more diffuse. Games have done that in the past with a variety of other filters. But here, from VSM's perspective, it's actually a bit more accurate than those in the past and doesn't have issues since it isn't done as like just a straight filter. It doesn't have issues when there's overlap. It actually looks quite good when there's moments of overlap in VSM because it is doing some form of tracing there. And this is what makes VSMs so unique. I don't think we've seen anything as similar across the variety of games we've looked at so far. It seems to be an Unreal Engine thing at the most part. And it does give you, at least for, I would say for sun shadows very specifically, like quality that rivals a lot of ray tracing. But as soon as you get into like larger, more complex local light shapes, like here surrounding me, there's a ring light, there's softboxes, etc. Like as soon as you get into the area light phenomena, where the light has different shapes to it, different sizes, it maybe covers 360 degrees. That's when VSM starts to break down both in quality and performance because, well, if you think about it, it can't match the shape of the light necessarily with a shadow map. And also the diffusion of the shadow may be so great that it becomes incredibly noisy or it becomes so inefficient to render that you should start using things like ray tracing to do the same effect. Mm-hmm. Triangle ray tracing. So it can rival, I would say, for things like sun shadows. It's a great alternative, but for other light types, you need something else maybe. And that's actually why Epic is making megalights, because they wanted to cover different light types and many lights. VSM doesn't scale to many lights like ray tracing does.
So to go back to Cottonbird's question, anything markedly different between other VSMs and other shadow techniques in terms of the end result seen by the player? I guess totally. Cascaded shadow maps are just basically a thing of the past, really.
Yeah, like the cascade, there technically is still like a cascade line in a VSM, I guess, but it's just so much more fine grained that you don't see it. Like that's one of the great parts about ray trace shadows and VSMs, at least, is that you just don't tend to see that big cascade line when you walk forward in a game world. And I think that's I love it. It's another getting rid of like a really harsh LOD behavior that we've seen in games for like 20 years and it's gone. So for the most part.
Good stuff. Let's move on. This question from Apothecary 2. Hello. I would like to genuinely like to hear your full perspectives on upscaling motion clarity and what aspects are actually most important. Since PS5 professional coverage started, there have been many cases even recently where PSSR demonstrated obviously superior motion clarity to other upscaling solutions, but Digital Foundry seem to acknowledge this, but downplay this fact and recommend other options based on how the still shots look. This has baffled many outside observers in the community. After all, aren't games mostly played in motion, especially since motion clarity has so frequently been a pain point in modern games, and is even the most common reason TAA haters state why they abstain from it. So you've looked at a lot of PSSR titles, Oliver. What's your take on this?
Yes. So I would say that motion clarity is one factor among many, and we have discussed the superiority of PSSR in terms of motion clarity, in terms of that sharpness in motion with PSSR. But I also think that image stability and clarity at rest is very important. Other factors like disocclusion handling is important, handling of ray tracing, SSR, other kinds of effects, very important. So there are a lot of factors. I personally have a bit of a bias here. Everyone has biases, but like I play on TVs that are usually a little bit laggier, and I like a motion blur. So to me, clarity and motion matters a little bit less to me personally. But any kind of popping or fizzling the image, aliasing artifacts, those annoy me. Any instability at rest annoys me. And then also keep in mind that in motion, it's harder to evaluate image clarity. So image clarity in stills, easier to see than image clarity in motion. You might be distracted by other things. You're distracted by the movement. You're not seeing the softness so much. That's why, historically speaking, when, DRS was more punishing in games before you had temporal upscalers, the idea was, well, in motion, you won't really notice the softness in the image when we turn on the DRS, when we kick it in. That was kind of part of the rationale behind it. And I think that certainly was the case, that people did not notice those kinds of apparent dips and deficits in image sharpness. But everyone will have their own preferences. If I'm evaluating a game with PSSR and I have enough time to look at image quality in detail, I will point out things that I think are relevant to the viewer. I will try to point out image clarity in motion. I'll point out all these other issues to the extent that I have time. And that will be colored by my own views and biases to some degree in the way that I convey it and the way that I prioritize those things. But I will try to give all information to the viewer. I will try to give you enough information, enough visuals, so you can make up your own mind. If you have a different set of priorities to mine, that's perfectly fine. Everyone has their own priorities when it comes to image quality. PC gamers have a different set of priorities. Console gamers have a different set of priorities. OLED owners have a different set of priorities. LCD owners have a different set of priorities, et cetera, et cetera. I could go on all day. But, it's just kind of like this kind of chain of what do you want to prioritize, what do you think is good, and PSSR does better in some aspects than others. I think that's quite clear, and image clarity and motion is one of the areas where it's kind of exceptional among upscalers. It does a very good job among upscalers.
Yeah, Alex, what do you think about this? I guess the other thing, of course, is that when dealing with motion clarity, you're also dealing with the quality of the actual display you're watching it on, bearing in mind the whole sample and hold phenomenon with flat panels. But curious what you think about this question.
Oliver pointing out he's on an LCD is important, but I'd also say that even like an OLED is insufficient, for all these purposes. Like as soon as anything's still moving, you're still getting a persistence issue without a strobe display. So especially at something like 60 hertz, even more so at 30 hertz. So I think the macro image look of something while it is moving, like the camera is turning, is very important. And one thing we've seen with PSSR in the past is that there's been as the camera is moving, at times there's been moments of intense flicker among post-processing elements in the screen. And that's something that Oliver quite obviously finds distracting. And I agree with his sentiment there, because that is a macro image. It's you can't avoid that. Yes, maybe the one moving thing has a better alias line on it or something. I don't know, or vice versa, or maybe it's especially clear. But if the entire image has other things that cause strobe effects, one thing that I always try and do with a game, and it's a little bit weird, but so when you look at something straight on, I think due to persistence, you can start ignoring certain effects. But as soon as you look at something less straight on, I think peripheral vision is more attuned, at least in our mind's eye, to issues of persistence. If I agree with that, is that the way around? Yeah, but either way, you can start seeing tons of flicker sometimes. If you look directly at a CRT screen, sometimes you don't see the flicker, but if you turn your eye to the right or left from the screen, it starts flickering like crazy. And that's a subjective thing. But sometimes when you're playing a game, and you've been playing it for so long, you don't realize actually how many problems there are with a lot of the visual aspects of it. And only if you bring in other examples or look at it a different way, then you start noticing it. So that's kind of cool. One of the great things about PC is you don't just have one or two image treatments. You've got a whole bunch. And as soon as you bring in a bunch of other image treatments, you can actually say, hey, maybe actually this image treatment type does something poor in comparison to this. And that's something you don't always have the luxury of on console. So that's another thing. You may be just used to something that is actually, in comparison to other things, not as good.
Mm-hmm. Yeah, it's also interesting, of course, that on PlayStation 5 Professional, a lot of games are offering the choice between upscalers, specifically because, PSSR as yet isn't like a one-size-fits-all perfect solution. Anyway, let's move on. Diehard X86 asks, all right, fellows, all right here. I've seen a lot of discussions in forums and on YouTube about the amount of RAM developers would like to see on the next generation consoles, handhelds, and PCs, and they aren't conservative. Upwards of 50 gigabytes, according to some developers, will be necessary to fully leverage the AI capabilities in these new chips, Magnus, Orion, etc. So my question is, will cross-gen be as drawn out this time around as Gen 9 was, considering the AI paradigm shift? Thank you, and to have a great weekend. Quick thoughts from me on this one. I don't think we're going to be seeing 50 gigabyte consoles. I think you've got to remember the whole point of the console, which possibly is less applicable to Xbox this time around, but ultimately a console is about producing a value-based piece of equipment that actually produces the biggest bang for the buck. And memory is expensive, ultimately. And this is why this generation, we saw, basically a 2x increase in memory over the last generation, which was an 8x increase. As to cross-gen for next generation, yes, it's going to be the biggest cross-generation I think you will ever have seen, simply because of the proliferation of devices that are out there, the continuing importance of PC, and the concept that developers and indeed platform holders are embracing the concept of a handheld. If the specs for the PlayStation handheld turn out to be true, it's going to be basically like a cut-down PlayStation 5 in certain respects. So that is going to be, holding back. Maybe holding back is the wrong word, but basically it means you're going to be looking at an increased scalability of devices that's going to be very reminiscent of cross-gen. But yeah, Alex, 50 gigs of memory in a console? Not likely.
Not. I would just hope not, because I don't think it would be a very price-efficient console like you were just describing. And I kind of do want to stick with I said it like maybe 4 or 5 months ago. I think I said like 24 gigs as a minimum and maximum. I kind of feel like that is like a sweet enough spot where you're increasing a good deal over the previous generation. And I don't think texture quality has been an issue right now, and it's just going to get better with all the ML techniques out there and new compression and I think we're going to see a more efficient usage of memory next gen as well too. So I think you don't need to balloon it too much, and I'm still pretty skeptical about the usage of larger models of AI in games. Maybe Microsoft proves me wrong. I don't know. But at the moment, I don't think you need so much more memory.
Right. I'm just thinking about, a lot of these expectations are from developers, not actual development documentation regarding next generation consoles. And I do remember one exchange I had with a developer where they said they wanted from PlayStation 5 8x GPU power of PlayStation 4 Pro. And I just sort of said, excuse me, 8x based PlayStation 5, I can kind of see it, and we kind of got that. But 8x PS4 Pro, no way, Jose. Oliver, what do you think about this? This whole question.
I think that all these comments about 50 gigabytes of RAM being necessary maybe come from people who are not super up on the state of the art at the moment, because modern AI models, at least many of them, are very, very heavily optimized. You can fit an LLM that works for a lot of purposes into like a gig or two nowadays. You can fit a voice synthesis model into a few hundred megabytes. You can fit, an AI upscaler like PSSR, into a small amount of memory as well, like 256 megabytes or 200 megabytes or whatnot. Now, there could be an exception to this, like if someone creates some crazy AI video model, some like Genie model for real-time graphics, you run it over game logic and you have this crazy game experience. Maybe that would require an enormous amount of memory. I have no idea. Something like that has not been yet invented, but perhaps that will come about. But absent that, these uses are not very memory intensive, and I'd venture that with, various enhancements to texture compression, perhaps you would end up with a reasonable amount of AI capabilities, even if you only had like 24 gigabytes of RAM or something similar. And of course, some of these uses don't require real-time speed and could be cloud-based. Indeed, you'd probably expect they would be cloud-based if they had to have some interoperability with last-generation consoles like a PlayStation 5, which cannot meaningfully accelerate. But I think that in terms of the cross-gen stuff, the cross-gen will last a very long time. The common hardware will be something like a PS5 or maybe a PS6 handheld. There will be a lot of cross-gen titles out there. I think it will last all through the end of next generation, I would expect. And I think games will be more scalable than ever because, you have the new handhelds coming out nowadays. You have like everything from a Van Gogh chip to like this PS6 chip, reportedly this PS6 handheld, and you have last generation consoles in the mix. Maybe, the Xboxes get dropped at some point, but certainly PS5. I mean, there are like 80 million PS5s out there. Those aren't being dropped anytime soon. Games have to reach a massive audience in order to recoup their budgets. I don't think cross-gen is going away anytime soon. I imagine it will be considerably longer than the cross-gen that we had between, say, PS4 and PS5.
Okay, let's crack on with this question from Super GT. Salutations, messers. Apparently, AMD Redstone has been developed using a project called ML2 code, which, if I understood correctly, runs the ML code in shaders. It appears to me, as far as ML, that AMD is betting on generalized hardware while Nvidia is betting on specialized hardware. What are your comments on this, and how would you relate this, if at all, to the shift from fixed function units to programmable shaders long ago? Alex, I think this came from a story saying that I think it was an interview with AMD that's recently surfaced suggesting that the Redstone features are going to basically work on any GPU, and this is apparently the way it's going to work. What do you reckon?
Microsoft has an extension to DirectX coming out, and it is out in a preview form in the drivers from Intel and Nvidia, and I guess AMD might even have it as of right now. I haven't checked. Called Cooperative Vectors, and that allows the respective driver from your IHV device, your GPU from Intel and AMD Nvidia, to leverage its machine learning specific hardware for code that was generically not written against it. So that was something that wasn't possible in the past and should be in the future. And I would imagine if this is the case for FSR Redstone and all those features for it, like the machine learning based frame gen, the ray reconstruction, and maybe even FSR4 itself, as in the super resolution component, well, then maybe it will be leveraging that, and that's why it runs on a variety of hardware. I almost feel like that would be just like a great end game for AMD to create like something that runs on everything and looks good enough, and then it disincentivizes developers to like even put in something like DLSS ray reconstruction, right? Because like, oh, the Redstone ray reconstruction is good enough. Like, let's just ship that. We don't have to do double the QA for different passes. So I almost feel like that would be a great thing. So that's my comment about the aspect of it running on different GPUs. But the question of like fixed function versus like a generalized bit of hardware that has some acceleration but less than fixed function unit, I think the first round of innovation occurs in fixed function, and then over time it starts to become more generalized in the past. But we are reaching the plateau of how small we can make transistors And I think as a result, that is less applicable now more than ever before. So I think that there is still a great benefit to using fixed function hardware for things for like even 10 to 15 years at a time, if not even longer. So I don't think that's going to be going. I think there's obviously benefits at it for not doing it, but I think specifically right now it is just so much more beneficial to have something like a Tensor Core than it is not. And I think a good example of that is you look at something like Switch 2. Like without the Tensor Core, it is not doing DLSS, not at all, right? Yet we have titles shipping with it. So I think that is a great showing of why it's very beneficial.
Let's move on to the final question to show from VicFix Corsa. Hello, DF team, exclamation point. With Nvidia buying a chunk of Intel, how does this increase the likelihood we'll get a console-like device with Nvidia graphics and x86 CPU architecture? The ship seems to have already sailed for PlayStation 6/Xbox, but does this partnership open up tantalizing possibilities for handhelds? I think it really depends on how you define a console for this, because the concept of actually creating a traditional style console that has its own ecosystem and APIs and stuff like that, I think that ship has sailed. We've got incumbents there that do this extremely well, in the form of Sony and Nintendo and historically Xbox. But, the direction of travel, certainly with the newer handhelds that are coming out, seems to be more to move into the PC space, certainly from the Xbox side. So I don't really see any kind of move from Intel and Nvidia into creating their own ecosystems. But certainly there's a lot of opportunity there to create some really compelling handheld devices that do have x86 CPU cores and NVIDIA graphics cores, and it is a tantalizing possibility, as this supporter says, by saying, just take a look at Switch 2 and what that's doing in terms of sheer efficiency and bang for the buck. It's really cool, and that's using an architecture from 2020. It's astonishing. So there's a lot to be excited about in terms of that collaboration. I think having an x86 CPU certainly makes things easier in terms of just adapting the current PC ecosystem into a new device like a handheld. ARM is still up in the air. The thing is that the Qualcomm laptops, the Snapdragon Elites, came out, and it was poor. It was a poor experience for gaming. You just didn't know whether that was the driver or whether it was the ARM translation layer, or a bit of both. Clearly, the ARM translation layer wasn't working when games wouldn't even boot, because there were problems with AVX instructions and stuff like that. However, there's the games that did work had such extreme stuttering problems for the most part that you can't help but think that was more likely to be a driver issue, which wouldn't be a problem for this, but we just don't really know there. So, obviously x86 just completely removes that as a possible problem just by removing that translation layer. Thing is, we are talking about devices that will be arriving years from now, which, by that time, maybe ARM is actually fully viable. What do you think, Oliver?
Yeah, I would hope so. For all the obvious reasons that you detailed, I think any effort like this would probably have to rely on Windows, using Xbox full screen experience or SteamOS, and it would be oriented around desktop software. So I do think you need to have a broader conception of what a console is or what it could be. I don't necessarily agree with that definition, but it's more like a console-like PC device, I think. Because I venture that if, Sony is probably going to stick with AMD, and then Nvidia and Nintendo have their own partnership that's very much separate from this effort. So I would think those would continue into the foreseeable future. But yeah, handhelds to me are very interesting for this kind of effort because, like we talked about earlier, they're limited in terms of what they can accommodate in terms of a discrete GPU and CPU, but you do want graphics performance there that exceeds the typical APU effort that you'd see from AMD, the typical kind of monolithic discrete little chip there from AMD, like a Strix Point. You'd want higher graphics performance than that has. But I think the question here is there enough of an ultra portable or handheld market to justify a design like this? Obviously, we're talking about a segment that has a really low volume of units. Maybe that increases in the future. I think a lot of people are banking on the ultra-portable kind of handheld sector becoming a larger and larger share of the PC gaming market, especially of the enthusiast PC gaming market. But it'll take a while for that to shake out. Maybe in the interim, there is not enough of a market to justify dedicating a lot of resources towards a single design that only really works in the context of we want graphics performance and super high features and a super low TDP envelope, and what can you do for us, NVIDIA? I'm not sure that necessarily is going to be too salient. But yeah, I think it'll be interesting to see what this market looks like, because you have AMD here in 2 or 3 years. Presumably we'll have like RDNA 5 APUs out there. I don't think Intel is standing still either. Presumably we'll have some new architectured chips, SoCs, based off of newer Intel cores and newer ARC architectures. And then you've got NVIDIA itself sitting here with like its N1X and N1 chips. Do those possibly figure into ultra-portables at all? That's also another tantalizing possibility, again, with very high graphics performance reported for those chips. So I think it's an interesting market. And I do wonder what the market will look like when these chips actually arrive, when these designs actually arrive in the market. If it'll be a market more like today, or if it'll be a market that's actually saturated with devices that are competing against each other, and they're all pretty good.
Yeah, my take on this is that it's a very small market, and it's most likely to be people licensing these chips in a similar way the Chinese manufacturers are doing for AMD stuff now. And those chips are actually mostly aimed at a different market, laptops potentially. But no sort of like dedicated effort from NVIDIA and Intel to produce a handheld. The ARM thing, maybe NVIDIA will produce some kind of device there, but who knows. Final thoughts on that, Alex?
Yeah, I think it would have been an interesting future if this came about in like 2017 or so, like where maybe the console manufacturers at that point in time, or even earlier, 2016, where it wasn't necessarily a given that they'd want to be sticking with AMD for everything, and there would have been more competition in that space for devices that could produce an SoC that still fulfilled the need to have x86 backwards compatibility. But this is way later than that, and Microsoft is doing their sideways shimmy out of the console market now. And the core people who are left, Nintendo and Sony, well, Sony's I don't see why would they move away from AMD? Like there's no good reason at this point. And Nintendo doesn't really need x86 probably. No. So it's just more, it's like very interesting for like what it does for this like middle range of computing for me, and specialized devices, laptops, the equivalent of whatever the Steam machine is that will eventually come out from Valve that is not a handheld, but maybe larger, and like an actual desktop. What if NVIDIA made something in that space, if that is a real space? Those are things that don't have much to do with consoles, though. So
I mean, I've kind of taken the question to mean sort of for handheld style devices, but it can mean anything really. And basically introduce a decent front end to a Windows based machine, and you've got a console like device really, which is I guess what Microsoft is aiming for with its full screen experience. I mean, I think it would be basically a small part of the market which would be addressed by a multitude of different devices as part of various OEMs' product lineups. But an interesting thought nonetheless. Anyway, there we are. That's the end of the show. So please do like, subscribe, share. If you enjoyed it, ring bells for notifications for you, potential algorithmic boosts for us. DF supporter program, please do consider that. Help to support the team and the work we make on patreon.com/digitalfoundry, store.digitalfoundry.net. If you wish to walk about in clothing that includes Digital Foundry messaging, which sounds great to me. but that's all from us on this one. Thanks for watching, and as always, thanks for supporting Digital Foundry. We'll see you next week.